Hello everybody and welcome back to our 38-part series about exponents in Algebra 1. This is part 4, rational exponents. Let's go ahead and jump right in and get started. So first of all, if we want to understand rational exponents, let's take a look at the root word present. Okay, the root word of rational is ratio, and ratio means fraction. So today we're going to be learning how to solve and evaluate questions like, what is 8 to the 2/3 power? We're going to come back to this specific problem. Okay, but in order to solve this, it's really helpful to think back to what we learned about exponents in previous classes. Remember, exponent just means repeated addition. And so these things that are, if you take, here I have my whole numbers counting up. 1 times itself is 1, or sorry, 2 times itself is 4, 3 times itself is 9, so on and so forth. These numbers in this list, where we take all of these and times them by themselves, these are called perfect squares. They're called perfect squares because if you take a square that is 3 inches by 3 inches, or you make a square 3 inches by 3 inches, there will be 9 square inches present. So that's kind of what that's called. And then over here, if we take a number and we cube it, that is, we multiply it 3 of them in a product, so 3 times 3 times 3, we get our perfect cubes. Okay, those are these numbers. And so these ones that are in bold, I would recommend you kind of just recognize they're going to come up over and over again. Your perfect squares. If you had a multiplication chart, these would be the numbers that are on the diagonal of that multiplication chart. So these are going to be helpful for us today. I'll be referencing back to this chart and how we might use that here in just a little bit. So today we're going to learn how to evaluate 8 2/3 and many other rational exponents. Let's go ahead and jump right into the meat and potatoes, the basic example that we're trying to highlight. Okay. So it turns out, if you have an exponent that is a fraction, you've been doing this the whole time. I really don't know why we as a country decide to teach radicals when we could just teach exponential form, and then we wouldn't have to do this lesson, but maybe it's simpler. So these two things are the same. I mean to say the square root of 16, so the square root of 16 is equal to 16 to the 1/2. They are exactly the same, okay? And so I'm going to go over the two forms and how they're similar and how they're different. Okay, so you've seen this before. Now, if you go and you take a look at like an iPhone calculator, there is no button that looks exactly like this. There's a button that looks like this with a 2, and there's a button that looks like this with the 3, and there's a button that looks like that with a Y, but there is no button with nothing there, okay? And that's because this is the square root, okay? This actually, on the iPhone, there's a little 2 right here. This 2 represents the square root, the thing that you guys are familiar with, okay? And this number that's right here can change. In fact, there are an infinite number of roots that you can take. This number right here is called the index, okay? And the 2 in the index in radical form is the same as whatever is in the denominator of our exponential form. So our index can be seen in the denominator of the fraction here. So all the examples we're going to start off with are going to have a 1 in the numerator. We're going to worry about different numbers later. But this index carries over here. So it's really important. I got to write this down exactly so we're not mixing anything up. But basically, what you need to know is that the square root of 16 is equal to 16 to the 1/2. They mean the same thing, two different ways to write the same thing, okay? Now, some of you are saying, all right, can you get to the answer already? You've been messing around, not telling me what I'm supposed to do. I'm trying to go over vocabulary. I got one more vocabulary word. This thing that is under the radical sign here is called the Radicand. And no, that is not a Pokemon. All right. And you guys know that the square root of 16 is 4, so that means that 16 to the 1/2 is also 4 because they're the same. It turns out that these two things ask the same question, and that question is, what number multiplied two times, I'm going to change the color. Okay, what number multiplied 2 times is 16? That's the question. Now, that's the question that this asks. All right, I'm going to get my green. I'm going to make sure you understand that whatever is in the denominator of the fraction in exponential form, whatever is the index or the number on our root, is this number. So let's write this in a general case. So I'm going to use, I have a computer here, so I'm going to take this, I'm going to copy, I'm going to paste. Let's go, team. Whoa. Try that again. Whee! All right, so I'm going to do a general case, and this is going to be kind of our next rule. This will be rule number 9. Rule number 9 says the following. Okay. Thank you for your patience. Rule number 9 is, or sorry, rule number 8. This is rule 8. Apologize. Rule number 8 is this. X to the 1 over n is equal to the nth root of x. Okay, and of course that n is the same blue n that I'm talking about right here. Okay, and it asks the same question. What number multiplied n times is x? Fantastic. So let's do a bunch of examples. I'm not going to stop. You guys can pause as soon after I write one down. I'm not going to stop because I'm going to be doing so many. I'm not going to stop for each. Okay? So let's go ahead and get started. Let's take a look at this first one. Here we go. All right, so in black, this asks the question, what number multiplied 2 times is 36? Now we go back to that chart that we had from the beginning. That chart said, what number multiplied 2 times is 36? You go down and go down. Aha, 6 is the number that is multiplied 2 times. It gives me 36. We can use that chart to the advantage. Okay? How we would write that as in radical form, this is in exponential form, is we're going to put a 2 right there. We'd write it like this. What number multiplied 2 times is 36? That number is 6. Hey, look, we're moving right along in purple. Okay, how about this one? Let's make it a little harder. This asks the question, what number multiplied 4 times is 16? So we would write that as the 4th root of 16. What number multiplied 4 times is 16? Well, we can go to our chart. 16, go all the way over. It is 2. And as you can see, each step that I go over, I'm multiplying by 2. Each step that I go over, I'm multiplying by 3. So if you wanted to construct the x to the 5th, you could. Okay. This one is 2, changing colors. In red, 27 to 1/3. Why don't you guys give this one a try? Talk about phrasing the question and then answer the question. And make sure you write it in radical form as well. 27 to the 1/3. What number multiplied 3 times is 27? That answer is 3. And let's do one more. You guys try this one on your own. 32 to the 1/5. Uh-oh, Slagle, there is no 5th column. You can do this. What number multiplied 5 times is 32? That number is 2. That is to say, 2 times 2 times 2 times 2 times 2 is 32. Cool beans. All right. All right, the next one that I want you to do is this. Will you guys tell me what is for example, what is 32 to the 1/3 power? 32 to the 1/3 power. Okay, so you say this is asking the question, what number multiplied 3 times is 32? Okay, so we go to our chart. We can go back. Multiplied 3 times, down, 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 down. Okay, it goes from 27 to 64. Hey, what's the deal, Slagle? 32 is not on the chart. There's no answer. No, there is an answer. Turns out that the number that we multiply 3 times to get 32 is an irrational number, and it is one that is a very, very long non-repeating decimal. So we're going to approximate that by using a calculator. And I'm going to teach you the ways that you do that. There are a couple ways that you can write it. And here they are. So you can use, depending on your calculator, there are lots of different ways, but you can do 32, and then some calculators have this little caret, like this, 32 caret, and then you would use parentheses. You have to use parentheses here, and you do 1 divided by 3. Okay, the other way to do it would be 32, and sometimes instead of the caret, it has this little button x to the y, or y to the x, or something like that, and you would do 1/3, and you can get your answer. Okay, and then the last way to do it is you can use a root. Some calculators have a root button. There might be a root to the x, or it just depends on the kind of calculator you have. Some of them calculate it this way, so you'd say 32 root to the x, and that's asking for the x, and then you type in 3, and that will work. And then sometimes these are swapped. So you just have to practice on your calculator. So let's go ahead and get this answer. What is this equal to, or approximately equal to? So I'm going to do a little decimal, go to my calculator, and I'm going to do 3. Mine, I have to plug the index in first. The answer is 3.17, about. It's about 3.17, and that should make sense. What number multiplied 3 times is 32? Well, what number multiplied 3 times was 27? 3. So this is probably going to be a little bit bigger. So if you go to your calculator and you type in 3.17 times 3.17 times 3.17, you're not going to get 32, but you get something really close, and that works. So you guys go ahead and now try this one on your own. What's 163 to the 3/5 power? Use your calculator to get your answer. Check your work. So don't move on until you can do this on your calculator, because I want you to be able to use this to check your work on tonight's assignment. Okay, you should get 21.2 approximately. Let's see if that, yeah, 21.2. Cool. And we haven't learned how to do it with something that's not 1 right there, but that's okay. You can just use your calculator to check your answer. So fantastic. Let's continue moving on, and we're going to do, hopefully this makes sense to you so far. So now I'm going to do a little math wizardry here. I'm going to do the same problem 2 times. And that problem is the one I gave you at the beginning of class, 8 to the 2/3. You actually have all of the mathematical knowledge to be able to do this right now. But you're going to have to be a little creative, so I'm going to kind of do things. So it's almost like we're doing them in reverse to what we're used to. I'm going to make things a little more complicated, but it'll make them simpler in the end. So 8 to the 2/3 is the same as 8 to the 2/1 times 1/3, right? Because if you multiply across the top, multiply across the bottom, you'll get 2/3. Okay, cool. All right, so this is actually rule 3. It's the opposite of rule. Remember in rule 3 we learned if you have something to a power and you raise that to a power, you can multiply the powers. Oh, so we must be raising 8 to the 2nd to the 1/3 power. Interesting. So I'm going to kind of go in reverse here. I'm going to write this as 8 to the 2nd raised to the 1/3. Oh my goodness. Hey, but you know what? We know what this is. We know that this is 8 to the 2nd the cube root of 8 to the second. And so what we are able to do is we can say, all right, well, 8 to the second, that's 64. And then we have a second question. We start on the inside and work our way outside. Start on the inside, work our way outside. What number multiplied 3 times is 64? We go back to our chart. Multiplied 3 times is 64. That number is 4. Okay, so great. We got our answer. This is fantastic. Fantastic. Great job. All right, now I'm going to do the same problem again. So this is way 1. Here's way 2. Okay, and so I don't know if you guys remember, but we can multiply in any order. 3 times 5 is the same as 5 times 3, so I could rewrite this as 1/3 times 2 over 1. Okay, so what's the big deal, Slagle? It's not very different. You're not changing things up. Well, it's changing the order that we're doing things a little bit. This now becomes 8 to the 1/3 over, or 8 to the 1/3 to the second power. Oh, so if we start on the inside, if we're supposed to start here, Mr. Slagle, are you telling me that I can take the cube root and then square it, and I'll get the same answer as if I square it and then take the cube root? That's exactly what I'm telling you. So that's how we process something that doesn't have a 1 in the numerator. It's going to involve us using an exponent at some point in the problem. So what this looks like is it looks like the cube root of 8 raised to the second power, which is the cube root of 8. What number multiplied 3 times is 8? Look at the chart. 2 times 2 times 2 is 8. So this is going to be 2 squared, which is 4. Okay, now I'm here to tell you, one of these methods is a lot simpler than the other. This one in the bottom, when you're dealing with numbers, it's harder to write, but it's a lot simpler to do math with the numbers that are present. So a lot easier, or a lot harder to write. You have to write the parentheses. It's a little more writing, but it's easier to do the calculations or think about the calculations, and you'll see why in just a second. This one is also good. In fact, it doesn't deserve a frowny face, but it's just not as good. He's kind of indifferent when you're trying to do a calculation, at least not for this assignment, because you make things bigger before you make them smaller. Here, we make things smaller, and then we make them bigger. And you can see this very apparently in the following example. So I'm going to do this example, and I'm going to do it using, actually, you know what? This gives birth to the rule number 9. I'm sorry for that metaphor, but rule number 9 with exponents is this, and you can actually use number 9 in place of rule number 8. Rule number 9 is any number a, non-zero number a, to the m, actually any number a, to the m over n is equal to the nth root of a to the m power, which is also equal to the nth root of a to the m power. So it doesn't matter the order. We can raise things to the m power first and then take the nth root, and then, or we can take the nth root and then raise the result of that to the n power. So I'm going to go through here. I'm going to pause the video. I'm going to go through and add some colors. All right, I've added some colors there. A to the m over n. Now you can kind of distinguish whatever's in the numerator. We end up exponentiating with that. And then whatever's in the denominator, we end up using as our index for our root. But we can do it in any order that we want. So how do you decide which to do, Mr. Slagle? Does it really matter? Yeah, it does. And I'm going to show you right now. So with this example, think about 27 to the 4/3 power. 27 to the 4/3. I'm going to do it two ways because I'm evil. The first way, I'm going to use this way here, which was the indifferent way, which means we raise 27 to the 4th power first, and then we take the 3rd root. So that's going to look like the 3rd root of 27 to the fourth. So to calculate this, we have to know what 27 to the fourth power is, right? Which I don't know what that is, so I'd have to use a calculator. And if you're going to use a calculator, you may as well just use a calculator from the very beginning, right? It's silly. So like, what are you doing? You're wasting my time. But you can do this in your head, and I'm going to show you how to do it in your head using the other way. So 27 to the fourth power is 531,441. And now this asks the question, what number multiplied 3 times is 531,441? Of course, that's tough, and it's really hard to know off the top of your head, so you'd use a calculator. Anyways, you're going to get the answer, 81. It's not easy, okay? Again, why are you doing this to me, right? How about this? How about we do it in the opposite order? How about instead we take the cube root of 27, and then we take the result of that, we raise that to the fourth power. Okay, let's do that. The cube root of 27, we've already done. What number multiplied 3 times is 27? That's 3. Okay, here we made here we made things bigger, but here we're making things smaller first, and then we make them bigger. So 3 to the fourth is 3 times 3 times 3 times 3. And then that's 9 times 9, which is also 81. Boy, that was a lot easier. No calculator required. No calculator. Okay, you try this one on your own. I want you to try this one on your own. Unpause the video when you're ready. 32 to the 3/5. 32 to the 3/5. On your mark, get set, go. Okay, I'm going to use the happy method here, which is the 5th root of 32 to the 3rd. What number multiplied 5 times is 32? Start on the inside of the parentheses, right? That's 2. 2 to the 3rd is 8. Done. Problem over. Okay, I'm feeling pretty good about this. The only other thing I'd like to add, you will be asked to go from, on your assignment, to go from exponential form like this to radical form, and you will be asked to go from radical form to exponential form. So just make sure you're using this rule. That's rule number 9. You're also going to be asked to evaluate those kinds of questions. So again, when you're going from radical to exponential, that would be like, if it's written like the 5th root of x to the 4th, you would write that as x to the 4/5, okay? Radical to exponential. If you're going from exponential to radical, that would be like 5 to the 2/3. You could write that in 2 different ways, and so either one is fine, but you could write it as the 3rd root of 5 to the 2nd. You could also write it as the 3rd root 5 raised to the 2nd power. Okay, and our last example for today is when you have a negative exponent that is also a fraction. Usually when I give this to students, they're just so discombobulated by this, they're not sure how to even get started, okay? Think about all of the rules that we have. We have a negative exponent. That means it's on the wrong side of the fraction, needs to be moved. That was rule number something, 5 or something. Look back on your, I don't have it in front of me. So I'm going to move that to the bottom. I'm going to leave a 1 in the top, and I'm going to change the power to be positive. Now I'm going to apply rule number 8. Anything to the 1/2 power, that's really the square root of 100. Well, what number times itself 2 times is equal to 100? Answer is 10. 1/10 is our answer. That's it. Yeah. Hope you enjoyed the video, and we will see you next time. Thanks for watching.